Okay, guys, here's my review of problem number 1 of FAA number 19, quiz 14 redo homework. Here's how I think about this. First, I look at the name, magnesium hydroxide and iron 3 nitrate. I know that magnesium is in group 2A, so I know it has to form an ion with a +2 charge. If I look in my naming book for hydroxide, the hydroxide ion has a -1 charge. That means that I need 2 hydroxides for every 1 magnesium. So the compound formula is MgOH2. I do the same thing for iron 3 nitrate. Iron 3, right away, we know it's Fe plus 3. If I look up nitrate on my naming book for polyatomic ions, it has a charge of -1. That means I need 3 nitrates for every 1 iron. So it would be FeNO3, 3. So that tells me right away that I need to rearrange some ions. So here's how I think about that. I think to myself, well, I know that I need a positive and a negative ion, so I'm going to have magnesium and nitrate joined together. So what I do is I just write the element symbols, and then I ask myself, okay, so let's see here. I need 2 nitrates for every 1 magnesium, since the charge of the whole compound needs to be 0. Now, I've intentionally made a mistake here to point something out in the next little bit. The next product will be the Fe plus 3 and OH minus 1. So I have Fe, and I know that each iron has a charge of +3 and each hydroxide has a charge of -1. So that would mean I would need 3 hydroxides in order to balance out the 1 iron charge. Now, I intentionally made a mistake here, and some of you guys probably picked it up. If you look in your at your rules for solubility, the compound magnesium nitrate is a nitrate compound. Well, rule number 1 tells us that salts of nitrate are soluble in water. So in fact, this is not the precipitate. This would be aqueous, which means we look at this and I say, well, hydroxide ions. If you look at rule number 5, rule number 5 tells you that salts of hydroxide are insoluble to slightly soluble, and the only exceptions are KOH and OH, which are soluble, and then barium hydroxide and calcium hydroxide are moderately soluble. So that would mean that this is insoluble, which means, in fact, that is the precipitate. So then what I do is I say, well, if this is aqueous, that means these ions need to be dissolved in water. And so I would have nitrate ions and magnesium ions in water. The precipitate is not written as its separate ions because if it's a solid in water, then it's not dissolving. So those ions are going to stay stuck together. Okay, the last piece I would need to do is I'd need to balance my chemical equation. And I think the easiest way to do this is to just look at the complete ionic equation. So if you look here, we have 1 part magnesium, 1 part magnesium, 1 part nitrate, 1 part nitrate. Over here I have 3 hydroxides and 1 iron. Well, I only have 1 hydroxide over here. So I'm going to first try and balance out those hydroxides. So, and in fact, if I look at my formula, I actually have 2 hydroxides over here, and I end up with 3 over here. So that 2, I'm going to carry that over, and this 3, I'm actually going to write that like this. So I have 3 nitrates and 2 hydroxides. Okay? So, and then actually I would have 2 of these over here. Da-da-da. Way to go, Mr. Matthews. Still not balanced because we have different numbers of each type of ion. And so what I do is I look at the 2's and the 3's and I think about what is the least common multiple of those 2 quantities. And the least common multiple of 2 and 3 is 6. So I would take my 2 OHs, and if I need 6 of those, then I'm going to have to put a 3 out here, and that means I'm going to need a 3 over here because I need 3 magnesiums. And so that would also give me 6 nitrates. So now this becomes 6. Over here, if I need 6 nitrates, that means I need 2 of these. So that gives me 2 irons, 6 nitrates, 6 hydroxides, 3 magnesium, and then over here we would have 2 FeOH, and then we have still our 3 magnesiums. Now, just to check that, we're going to look at our charges here. This is +6 is my charge from this. This is going to be -6 because there are 6 minus 1s. 2 plus 3s is +6. 6 minus 1s is -6. If you notice, our net charge of everything is 0. Over here, the net charge of this whole thing is 0 because it's a compound. Then I have +6 and -6. So that tells me that the net charge on both sides is 0 as well. Now we want to be able to represent this with a drawing. So the way that we're going to do that is I'm just going to draw in some water, and I'm going to have 3 Mg plus 2s. I'm also going to have 6 OHs. It's going to get full in here. And I'm also going to have 2 irons. And then I need 6 nitrates, all squeezed in here. So write small, -1, and I'm going to get lazy and write ×6. Okay, so then after the reaction, we still have water, and you're going to have 6 magnesiums. I'm going to get lazy again. And you're going to have 6 nitrates that are going to be floating around in solution. And then you're going to have a solid precipitate at the bottom. And that is going to be 2 parts FeOH3. The name of this compound, since it's our precipitate, is iron 3 hydroxide. All right, please make any corrections to your paper in a different color of pen just to show that you've made your corrections. You're getting points based on completion. I'm giving you the answers, so I will look for 2 different colors of writing if any mistakes were made. If no mistakes were made, that's fine. You should just continue to do the assignment. Okay, good luck, guys.